Welcome everyone. In this session, let's solve some problem from exercise 8.1. This is the second problem. In figure 8.13, find tan P minus cot R. The figure PQR is given where PQ is 12 cm and PR is 13 cm. To solve the solutions, at the very first step, let's try to find the third side QR. Okay, using the Pythagoras theorem. What is the Pythagoras theorem? Hypotenuse square equals side square plus side square, which is PR square equal PQ square plus QR square. Let's substitute the value of PQ and PR to find QR. So 13 square equal 12 square plus QR square. For 13 square 169, for 12 square 144 plus QR square. Let's bring this value to other side. So 169 minus 144 equal QR square. So the answer is QR 5. Let's write the value on the figure 5 centimeter. Now we know all three values. Let's try to solve the tan P first. So tan P is equal, so here the angle is P, okay. So we know that tan theta equal opposite by adjacent, so which is 5 centimeter by 12 centimeter. Here opposite side is QR, adjacent is PQ. The next is cot R. So cot R, here the angle is R, not P. So be careful, don't write the reciprocal of tan P, because we have to write the reciprocal of tan R. So let's find out the tan R first. Now the opposite side is PQ, adjacent is QR. So 12 by 5. For tan R equal 12 by 5. So for cot R, it is a reciprocal of tan R, so 5 by 12. Next step, let's find out tan P minus cot R. So 5 by 12 minus 5 by 12, so 12 is the common denominator, which is LCM. So 5 minus 5 is 0. If numerator is 0, the whole term is 0. So the answer is 0. Okay, let's move on to the third problem. If sin A equal 3 by 4, calculate cos A and tan A. So first of all, let's try to draw the figure, okay. So I draw one right angle triangle. I am going to name them as A, B, C. So make sure that the A is not 90 degree, right? Otherwise we cannot find these values. The values are not possible, okay. So let's try to do. So for sin A is, what is sin A? Opposite by hypotenuse. So here the value is given 3 by 4. So the value 3 is opposite side, the value 4 is hypotenuse. So let me write, here is the angle theta. So opposite is this side BC. So I am going to write 3 for opposite side. For hypotenuse, this is the always hypotenuse, right, opposite to the 90 degree. So opposite side is 3 and hypotenuse is 4. So what we have to do next? We have to find the third side, which is AB, using the Pythagoras theorem. We all know that AC square equal AB square plus BC square. Okay, after substitution AB square equals 7. So AB equal, take root, right? So root 7. So we cannot take the value out. You simply keep as it is, root 7, okay. First let's write the value, here is root 7. Okay, next step, cos A is adjacent by opposite, hypotenuse, right. Always make sure with the theta, here A only, okay. So we don't need to change the place, okay. Cos A equal to adjacent, now adjacent is root 7, for hypotenuse is 4, for tan A, opposite by adjacent. So 3 by root 7. 15 cot A equal 8. Find sin A and secant A. First of all, let's try to find what are the values we can obtain from this given question. So here 15 cot A equal 8. So here I write 15 cot A equal 8. We can derive cot A. So cot A equal, we can write 8 by 15. Like we used to do with some numbers. For example, xy equals 15, y equals 15 by x, right? This is how we done this. Next we know that cot A equal, it's a reciprocal of tan A, which means adjacent by opposite side. So tan A is opposite by adjacent, so cot A is adjacent by opposite. Okay, let's try to draw one right angle triangle with those values. So look at here angle is A. So here angle must not be 90 degrees. So I write A here, though this way I name the triangle ABC. So A must not be 90 degree. So if this is the angle, what is the opposite side? Sorry, adjacent side is this one, AB. So 8, for opposite side is this one, 15. Next step we are going to find the third side hypotenuse AC using the Pythagoras theorem. For 8 square 64, for 15 square 225. So when you add these two, 289 is for AC square. For AC, root 29 is root 289 is 17. So let's write the value 17 here. Next step is going to be very easy. We are going to find sin A and secant A. So first sin A is opposite by hypotenuse. So 15 by 17. Make sure the angle is A, right? Next step secant A. So secant A is reciprocal of cos A. So you better first find out cos A. So cos A is adjacent by hypotenuse. So 8 by 17. So secant is the reverse reciprocal. So secant A equal 17 by 8. Let's move on to the fifth problem. Given secant theta equal 13, calculate all other trigonometric ratios. Sorry, here 13 by 12. Now let's draw the triangle, and I am considering theta here. So, and the secant theta we know that hypotenuse by adjacent, right? So let me substitute the value for hypotenuse and adjacent. In the next step I am finding out the third side, which is AB, using the Pythagoras theorem. After substituting the value, I got AB equal 5. So now we know all the values. So let's find out what we asked to find out, all other trigonometric ratios. If secant theta is given, so we are going to find first sin theta, cos theta, tan theta in the ratio method.